Hello there, warriors. This is Miss Lemons, and today we are going to be introducing ourselves to the electromagnetic spectrum, which classifies all types of waves of light. So we know that waves are characterized by three variables: frequency, which is measured in hertz and represented with a lowercase f; wavelength, which is measured in meters and is represented with lambda; and energy, which is measured in joules and is represented with the variable capital letter E. Now, these three variables are all on the electromagnetic spectrum. So this right here is the electromagnetic spectrum that we're looking at. And you can see that there's a lot of stuff going on here. So I just want to walk through with you each of the different variables and how they relate to each other. You also need to be familiar with the different variables and how they relate to each other. So first, let's take a look at the first top chunk here, which is the wavelength chunk. You can see that we have the names of each of the waves that are featured. They are radio, microwave, infrared, visible, ultraviolet, X-ray, and gamma ray. And as we move left to right across the EM spectrum, the wavelength, we can see it down here, the wavelength is getting shorter. We can also see that numerically, right? So as we move left to right across the EM spectrum, we are decreasing in wavelength, right? The waves are getting closer together, they're shorter, okay? The other chunk of the electromagnetic spectrum is the frequency chunk down here on the bottom. You can see that as we move left to right across the EM spectrum, numerically, that the frequency increases. Now, think about this logically. What frequency means is how often something happens. So if you have a really large wavelength, that means that the waves are happening less frequently. If you have a really small wavelength, that means that the waves are happening more frequently. So high frequency, low wavelength; low frequency, high wavelength or large wavelength. The last chunk of the spectrum that we should pay attention to is the center part, energy. And there isn't really any numeric value attached to this, but you just need to know that frequency and energy both increase as we move left to right across the spectrum. And I kind of have a memory trick for remembering that energy and frequency are related, or they are directly proportional. On the bottom of the spectrum, you can see that we have this little rainbow. This right here is the visible spectrum, and it's almost smack dab in the middle of the EM spectrum. The visible spectrum, as its name would imply, is the spectrum or portion of the spectrum that we can see with our own eyes. So anything that you visualize and perceive in the world is because of the visible spectrum. Once we go too high or too low in wavelength, we can no longer see those waves, but we may experience those waves in different ways. Let me show you what I mean by that. So you do need to be familiar with the order of the EM spectrum. You can use the acronym, which is RMIVUXG. That's radio, micro, infrared, visible, UV, X-ray, and gamma. Or you can use the mnemonic, raging Martians invaded Venus using X-ray guns. If you are a fan of a little memory trick like that, by all means, jot this down and keep it in your notes so that you're ready for your test and quiz. But I actually prefer to think of each wave as far as how dangerous they are. So here is the EM spectrum visualized a different way. The real world applications for each of these waves. What are they? How do we interact with them? And how can I use the way we use them to help me remember the order that these waves go in? So on the lowest end of the spectrum, over here on the left-hand side, the waves with the longest wavelength, these are going to be your radio waves. Now think about this. It actually makes a lot of sense that radio waves have the longest wavelength because they travel millions of miles. We use radio waves to send signals out into space. We also use radio waves to listen to music from Milwaukee on 88.9 FM. What is 88.9? That's a frequency that you're dialing into. Pretty cool, right? Now, we know that these waves aren't dangerous. They don't hurt us. They're constantly flying through the airs. We're listening to music on the radio. So low danger means low energy. The next type of wave on the spectrum is a microwave. Microwaves aren't really that dangerous. I mean, obviously, we cook our food with them. You don't want to put a living thing inside a microwave. That's not good. But we keep it all inside the little microwave. They're not dangerous. We go up a little bit more in energy. We increase the danger a bit, and now we're into infrared. Now, humans cannot visualize the infrared spectrum. That's heat mapping. We can see that with this picture here. They transmit heat from various sources. We know that snakes have some form of infrared visualizing, right? They can actually experience the infrared spectrum different than us. Then we get into the visible spectrum. Red will always be the lowest in energy with the largest wavelength, and it butts up right next to infrared, right? Red, infrared. And then we go through the rest of the visible spectrum all the way up to violet. Violet is violent, is really my memory trick. It's violent. It's the most dangerous, I guess, of the colors. It has the shortest wavelength, and it has a high frequency and a high energy. Now that we're getting into this second half of the EM spectrum, we are now getting into what's called ionizing radiation. Ionizing radiation is dangerous. It can hurt you. And a good example of that would be what's higher than violet, ultraviolet. These are the waves that come from the sun. We put sunscreen on to prevent UV rays from tearing apart our cells and causing cancer. It does take a lot of sunlight and a lot of sun exposure to get cancer from the sun, but it is possible. We're going to increase the danger and increase the frequency of our waves by moving into the next one, which is the X-ray. Now, X-rays allow us to peer into the human body, which is super cool. But remember, we need to have protection while we're getting our X-rays done. So I don't know if you've ever been to the dentist, but the dentist, when they take X-rays of your face or your teeth, they put this heavy lead apron on your body. And the reason why they do that is because the X-rays that are coming out of the machine, they're not ideal to be inside your body. They can cause cancer. And so that lead blanket or apron they put on you blocks the X-rays from going into your body. And that way they can only direct the X-rays where they need them. Now, just like the sun, you need quite a bit of exposure to X-rays in order to cause cancer, but they can be dangerous. So high energy. And then the highest energy of all is going to be the gamma waves. Gamma waves are super teeny tiny waves, really, really small wavelengths, very high frequency. And it's actually gamma rays or gamma waves. That is the reason why the Chernobyl nuclear center in Pripyat, Ukraine is so dangerous. Anything that emits radioactivity in the terms that you are familiar with typically is emitting gamma rays. These are extremely dangerous, and they're the reason why the myth, the legend, the Hulk exists. He was created by gamma rays. So if you just think of each of the waves in terms of how dangerous they are, the most dangerous, your gamma waves, are going to have the highest energy, the highest frequency, and the tiniest wavelength because it's easy to get into your body. Whereas radio waves are going to have the longest wavelength with the shortest frequency or the smallest frequency. They don't happen as frequently. And the lowest energy. They're not very dangerous, and they can travel millions of miles. When it comes to the visible spectrum, remember that red has a high wavelength and is right next to infrared, and that violet is violent and it has a low wavelength and high energy and is right next to ultraviolet, which comes from the sun. So ultimately, in addition to knowing like the order of the EM spectrum, we also need to know the mathematical relationship between each of these three variables. So, for instance, as wavelength increases, so going right to left, the frequency decreases, right? As the wavelengths get longer, they become less frequent, which means our energy also decreases. This is called an inverse proportion. As one variable increases, the other variable decreases. If we look at the relationship between frequency and energy, though, as we move left to right across the EM spectrum, as frequency increases, the energy also increases. This is called a direct proportion. As one variable increases, the other variable increases. And then obviously the opposite would be true. So as one variable decreases, the other variable decreases. So this was your introduction to the electromagnetic spectrum. Take a moment now to answer the questions on your worksheet.